So who's your favorite drummer? John Bonham was pretty good. Ginger Baker was a genius. Topper from The Clash made the type of noise I like to hear. I'd like to tell you about a drum beat in organic chemistry, and it's called resonance. In many organic ions, the charge stays where it is. It's locked, like on chloride. But in some anions, where the charge is conjugated with double bonds, it moves. To predict where a charge moves to, you've got to remember how to push curly arrows. Do you remember my workbook for sophomore organic chemistry on this? It will train you how to push curly arrows. If we push the curly arrows, the charge moves from here to here. In some cases, like this allyl anion, unsubstituted, it doesn't appear that the charge moves at all. But it does. Is the movement random? No, it's not, because it's defined by the way the electrons flow using these curly arrows. And that tells you that the charge moves from one point to another point, but it may skip an atom. It never ends up in some positions. Imagine you're a hungry electrophile. You're starving, you're looking for electrons. You want a negative charge to react with. If you're that electrophile, would you react here? Would you react here? Would you react here? But there's no charge there. Understanding resonance lets us know where the charges are moving, and that enables us to predict reactivity. And if we can do that, we understand much more about organic transformations, which is what introductory organic chemistry is all about. Where a molecule might react, in other words, the reactivity and the regioselectivity of that reaction. And you also understand where the molecule is never going to react. And that's important too for ruling out options. So you can predict the outcome of reactions like this. Can you predict what would happen if we treated this molecule with a strong base and then an electrophile? Where might it add? If you can do that, you're predicting the reactivity and the regioselectivity of the reaction. And that's good, you need that skill. Resonance, you gotta love it. It's an offer you cannot refuse, because if you don't understand it, then it'll come back and bite you over and over again in sophomore organic chemistry, and you won't do very well on the quizzes and exams. I challenge you, can you predict the outcome of a reaction like this? Where would that molecule react with this nucleophile? If you can't do that already, maybe you understand vaguely what resonance is, but you haven't mastered the concept. You can't apply it yet. Mastering concepts so you can apply them freely is the trick in sophomore organic chemistry. So that's why I wrote my little workbooks with an attitude. They're all problems. They come at you from all different directions. They ask you questions in all different flavors, because then you can recognize all different types of questions on the exam. They're available from Apple Books. They have embedded videos. The answers are online, and it will cost you about half what a cup of coffee costs. And I'm writing these because I would like to help students. If you buy my book, if you download it, I feel validated. It gives me motivation to carry on. So if you've done that, or you intend to, thank you very much. And thank you for listening. Bye-bye.